So we've reached question 4. And question 4 was about a range of possible values. So we've answered everything about probabilities and about pictures, but now the principal is interested about a range of values. So the principal knows that we're dealing with samples. We finally managed to show the principal the problem of assuming that the population is normal with the same characteristics as last year. So the principal said, okay, so let's deal with samples. And can you give me a range of possible values? So for example, the mean, the average or the mean mark in maths, can we come up with a possible range of values? An answer, for example, like the mean mark in maths is going to be between 45% and 50%, something of that sort. All right, so we can never know the real answer because we don't know the population, but from the sample, we can get a range of possible values for the mean mark. That's the whole idea. And this is called a confidence interval, right, for the mean. And in this lesson, we're going to learn how to construct a confidence interval. For now, using a Z distribution, later on, we'll see what a T distribution is, okay? So, well, actually, the principal also asked, what if I have a possible range of values for the overall mean or average? We'll try to answer that as well, okay? That is our goal. Now, let's go back to our previous calculation we had here that we were doing before. Now, I told you before about the sampling distribution, and we agreed that the sampling distribution is there to give us predictions about the sample, right? And frankly, the sample is not interesting. What we want is the population of the sample. But I'm going to show you how we can get very interesting information from the sampling distribution formula and come up with a range of values, okay? But before I do this, I'd like to explain a little bit about the concept of level of significance. Now, level of significance is the area that is not covered. From a purely probabilistic point of view, if I have my alpha equal to 5%, it means that I am leaving out 2.5% on the left and 2.5% on the right uncovered area, all right? Which has the following interpretation, all right? My area covers 95% of the population, but this is statistics. We can never cover the entire population. To cover the entire population, we would need the whole population. It's a census, not a sample, right? So there is 2.5% on the left and 2.5% of the right, which is 5% in total, of my population that I am not covering with my sample. The mathematical reason is a bit more involved, but I would like you to understand the basic intuition. The information I'm getting about the sample covers only 95% of the population, for example. I could put it to 2% or 1%. But let's say I want to cover 5%, sorry, let's say I want to cover 95% of the population. We call this, I want to be 95% confident. All right? What we mean here is this. My sample is representing 95% of the cases in the population, but my alpha, this alpha here, 100% minus 5% is minus 95%, is 5%, which means you are letting 5% or 2.5% on each side uncertain, all right, uncovered in the population. I'm not being very, very precise, but I'm trying to convey the intuition, right? And we will always have a blank area because we're doing statistics. We don't know the whole population, all right? The symbol for this number is alpha, and the Z values and values in plural values is Z alpha on 2. Why alpha on 2? Because we split it in two parts, because a normal distribution has two tails, left-hand side, right-hand side. So the 5% has been split into alpha on 2 okay? Which means you're leaving 2.5% of the area uncovered on the left and 2.5% of your area uncovered to the right, okay? So my Z number, plus and minus, is my number, my positive number here, and my negative number here, all right, which are the thresholds. Beyond this number is uncovered. Beyond this number is uncovered. All right, but from minus Z alpha on 2 to plus Z alpha on 2, you are covered, which means your sample is representing 95% of the population. Okay, that is important to keep in mind. Now, by the way, in every question, you're going to give in the level of significance or how confident you want to be. Now, let's go back to this formula. This is the formula I gave you in the previous lesson, which we said gives you information about the sample. This is the sampling distribution formula. And we said we really don't care about this, about the sample. But I'm going to use this to come up with information on something that we really care about, which is the population mean. Let's see how to do that. So what I'm going to do now is I'm going to put mu subject of the formula. All right, I'm going to put mu subject of the formula. So I'm going to take this upstairs. But remember, you have two values here, plus and minus. Don't forget that. So this guy here goes upstairs. So I have plus and minus z times sigma root n equals x bar minus mu. Then I put mu subjects. So I take mu on the left-hand side, it becomes positive, and plus and minus z alpha onto sigma over root n comes to the side. So it's plus and minus, right? So I simply put mu subject of the formula. But what is this? This is two calculations packed in one, because I have mean plus z sigma root n. By the way, I have removed the alpha on 2. There is still an alpha on 2, but I have removed it not to clutter the notation. Anyway, I was saying, I have two calculations packed into one. I have the plus part, x bar plus this, and the minus part, x bar minus this. But didn't we want a range of values? And that's exactly what a confidence interval is. Because when I work it out with the negative parts, I get the lower value, the lower, let's call it the lower bound, the lower value. When I work it with the positive parts, I get the upper bound, the upper value. And what do I get? I get a range of possible values for the true population mean, which is extremely, extremely important. Something like this will give me an answer to the question I solved before. For example, what is a range of possible values for the mean in maths or the mean grade in the final exam? All right, so that is exactly what a confidence interval is. Now, of course, everything depends on the z, right? If I am 95% confident, it means my alpha is 2.5%. So in the next lesson, I show you how to find that z for 2.5%. What if I am 99% confident? Well, it means that, let's draw it here. Let's draw it here. If I am 99% confident, I'm going to repeat this again in the next lesson, but anyway, a little spoiler. If I am 99% confident, then I'm leaving 1% total area blank. So 0.5% blank in here and 0.5% blank in here. So that z would be the number, negative and positive, that gives you these blanks, all right, which I will show you how to do in the next lesson.